Good evening. Our main theme this evening is comets, but I must start by saying something about the Sun, because the Sun has been behaving in the most unusual way. We should be well past the maximum of the solar cycle, and yet we had some amazingly large sunspots. Look at this lovely setup at Douglas Arnold. They are huge spots, and they produce the biggest flare that ever been seen, and that was not expected. Pictures too, some from the Soho satellite. And from the Big Bear Observatory in Canada. At the same time, these solar outbursts produced magnificent displays of aurorae, or polar lights, and they were seen from here. Look at this picture by Martin Moberly, taken from Middle England. From Fife, a picture by Alan Clitheroe. And some lovely pictures from Orkney, taken by Carl Vetterlein. And the aurorae, well, they were seen from down here. There may be some more to come, we don't know, but certainly the Sun had been behaving in a very strange kind of way, and we don't know why. There have also been two eclipses. We had a total eclipse of the moon, photographed here by Nick Shamonic and by Brian Wilson. I didn't see that one, I was clouded out. And then the total eclipse of the Sun. The track crossed the Antarctic continent, enjoyed by the penguins and by the few people who saw it. Must have been a spectacular sight.
5, 4, 3, 2, 1. Diamond ring, and there's the Comet.
Oh, bless. Absolutely incredible. Oh, my God.
So now, on to our constellation of the month. We've dealt with the two bears, the Cassiopeia. Now let's turn to the dragon, celestial dragon Draco, which sprawled between the two bears, and there we have the old pole star Thuban, and the tail of the dragon with one fairly bright star, Elderman, not far from Vega. Not a very distinctive constellation, but well worth finding. And now on to our main theme, comets. Now I begin with a small comet, an old friend, Comet Encke, now visible with binoculars in the constellation Ophiuchus. That's a small comet. It's come back every 3 1/3 years, but for our brighter ones, we may have 2 bright comets in the spring. Who knows? And of course, at the moment, there are various probes on their way to comets. And delighted now to welcome back, all the way from Canary Islands, Mark Kidger. Welcome back, Mark.
Very pleased to be here, Patrick.
And what about these various comet probes?
Well, Comet Encke was a good one to start with because there should have been a probe called Contour, an American probe for NASA, that was going to pass by Encke on November 12th.
Of blessed memory.
As far as we know, it did, or at least a bit of it did, because it launched successfully. Then NASA lost contact with it as it blasted out of Earth orbit. A photograph was taken from the Spacewatch telescope in Arizona, and it did show the probe. Unfortunately, it also showed 2 other large pieces going in the same direction. There is one piece, a very faint piece, that was right where the probe should have been, and as far as we can tell, that probably did encounter Comet Encke, but totally incapable of contacting the Earth. It appears to have blown up. There was some failure with the main engine. It blew up, which is a pity, because then, in 2006, it would have gone on to another comet, a really interesting one called Schwarzmann-Wachmann 3. That's a comet that in 1995, when it passed close to the Sun, suddenly brightened. It had an enormous outburst at perihelion, brightened 6 magnitudes, about 250 times. And afterwards, astronomers detected 5 fragments of the comet. Obviously, the comet had broken up quite severely. Now, it would have been fascinating for a probe to go to a comet that has just recently broken up like that and look and see why. Because we don't know.
No, we don't know why.
Nobody knows why they break up.
No, we don't. And what about the current probes?
Well, the first one in the sequence is Stardust. Now, Stardust will go through another very faint comet. It's one called Wild 2, which is visible. You can't quite see it in binoculars. It's about magnitude 10, and it will go through the comet on January the 2nd next year. Now, this is a most curious mission, because this probe will pass at 150 kilometers from the nucleus of the comet, going at about 6 kilometers per second, so it's fairly fast. And what it has got is a sort of fishing net which hangs up above the probe, and as it flies through the comet, this fishing net is going to catch bits of dust from the comet and material from the comet, and then it will return them to the Earth. And the idea is that in 2006, the probe will return to the Earth. This fishing net will be separated, it will parachute down into the Utah Desert, and scientists will recover it, and we will finally have material from a comet on Earth. We'll be able to study it. That will be fascinating.
It will indeed. There are those two.
Yes, there are two other particular missions that are due for launch next year. The first one to be launched is actually the last one to arrive. That's the Rosetta mission, the one that's been delayed. That will launch towards the end of next year. It will go to a comet called Churyumov-Gerasimenko,
Right.
after two Russian astronomers who discovered it. That probe will arrive in summer 2014. It goes by the scenic route, I'm afraid. Arrive in summer 2014. It will go into orbit around the nucleus of the comet, 30 kilometers altitude, so very close to the nucleus. And it will continue orbiting for at least a year, and it will drop a little probe on the surface of the comet. And this probe will analyze the composition of the comet, its structure. It carries a lot of experiments, and that probe will continue to operate for at least a year, maybe more. And then the last probe to be launched, in some ways, is the most spectacular. That's a probe called Deep Impact. That will be launched just after Christmas next year, and it will go to a very small, faint comet called Tempel 1.
Yes.
The Deep Impact probe will fly past the comet very close, and 2 hours before closest approach, it will separate an impact probe. It's literally a large copper cylinder, 350 kilograms. It will hit the comet at 10 kilometers per second. That will be a tremendous impact in the comet.
It may damage the comet badly.
That's the idea, actually. We want to see what happens, because the only way of discovering what the structure of the comet is to see what it looks like inside. You make a crater. Now, NASA officially estimates the crater will be about 100 meters across and about 25 meters deep. So we'll dig inside the comet and we'll see what it's like inside, because Tempel 1 is a dying comet. Is it dying because it's running out of ice inside? There's just no more ice left. Or is it dying, as a lot of scientists think now, because over the years a thick insulating blanket of dust forms and stops the sun's heat from penetrating inside and warming the ice? That's the theory that most people believe now. We'll see, because it will excavate that crater, and we'll see what's underneath, if there is still ice there.
We have at least some idea now of what the comet's made up of.
Well, a comet, traditionally we talk of it as a sort of dirty snowball. But one of the problems is that over the last few years, people have started to realize that the idea that we've had for something like 50 years, since Fred Whipple suggested in 1950 that a comet is a dirty snowball, is actually not as accurate as we thought. People are not too sure what a comet is really like inside. And one of the ideas that people are having is that a comet is really a whole lot of blocks of ice and snow held together, possibly, or maybe even not held together. They may even be very, very fragile objects that just fall apart very easily indeed.
Of course, we have seen one or two nuclei. We saw Halley's Comet.
We saw Halley's Comet, and we've seen the nucleus of Comet Borrelli, and they look remarkably similar. They're very, very dark, very black objects, which was a complete surprise, because when the Giotto mission was planned for its 1986 encounter with Halley, they expected to see a bright, shiny object, and it wasn't.
No, it wasn't.
And that's why we didn't see it on the images that night, because the cameras were programmed to track the brightest object in the field of view, and nobody realized at the time the nucleus was just sliding out of the field of view. It wasn't until next morning that people actually realized where the nucleus had been on the photographs.
One person did, of course, was Fred Hoyle. He got it right.
Yes, but on the night, I was watching the videos from Darmstadt. You were there at Darmstadt yourself, and nobody could actually point to a photograph and say, there's the nucleus. It was next morning.
Strange business, that. I remember that program very well. Now, what about the origin of comets, Mark?
Right. There again, ideas have changed over the last few years. Now, we know that there are two clouds of comets around the solar system. There's the Kuiper belt, which starts at about the orbit of Neptune, and it extends outwards past Pluto, probably to a distance of several thousand astronomical units from the Sun, several thousand times the distance of the Earth from the Sun. And then there's the Oort cloud, which is the big cloud of comets round the Sun, and that extends out halfway to the nearest star, several light years distance, and the most distant comets may be being swapped between the Sun and other nearby stars. Now, people had thought for a long time that comets originated in the Oort cloud. In fact, those ideas are changing. It seems that comets actually originated in the Kuiper belt. They're remnants, what was left over from the formation of the solar system, the bits that didn't go into the planets. And over the years, some of those comets came into the inner solar system, others were thrown outwards, and the Oort cloud formed from comets that had been thrown out of the solar system out into the most distant reaches. And the Oort cloud is a sort of storage space for comets. But as far as we can tell, most of the comets probably formed a lot closer to the Sun.
We have had bright comets recently. Of course, Hale-Bopp was a classic.
Oh, Hale-Bopp was wonderful. 19 months visible with the naked eye, which is by such a huge margin a record. And it's still quite bright. In the southern hemisphere, it's still quite easily visible with amateur telescopes. It's still quite active. It's beyond the orbit of Uranus now.
And it did have a nice multiple tail.
Yes, it was a very spectacular object indeed. A comet like that comes around about every 300 years, and how lucky we were to see it there.
It was a marvellous comet.
It was, and Hyakutake just before it.
And of course, tails are formed by the solar wind and light pressure.
Yes, this is true, and the effect, you know, for people who don't understand how a comet forms, it's just like smoke from a chimney, and it's about, well, it's not even as dense as smoke from a chimney, and people know the effect. You see a chimney, there's a little bit of wind, it blows the smoke away, and that's the same as the tail of a comet. The solar wind blows the material away, and even though the tail looks spectacular, there is very, very, very little mass there.
Comets are fragile things, and by solar system standards, they are short-lived. I mean, they can disintegrate. We've seen that.
Yes, exactly. Even Halley's Comet, which is a rather big comet, calculations have been made. We think that Halley's Comet has probably gone round the Sun about 3,000 times. Now, if you multiply 76 years by 3,000 times, that's not very long.
No, it's not.
And it will survive maybe about another 3,000 times more. And that seems to be about typical, that a big comet might last maybe 10,000 orbits round the Sun, a small comet maybe only 1,000. And a comet like Encke is a comet that's dying.
Yes.
It was probably a very spectacular comet a few 100,000 years ago, but now it's dying out. Halley's Comet as well, probably in its early life was very, very spectacular object, and even now, after 3,000 orbits, it's still pretty good.
Well, Hale-Bopp was good. It was a lovely comet, but not really a great comet in that respect. I mean, there have been comets that cast shadows.
Yes, well, Hale-Bopp, we were just very, very unlucky. Now, if Hale-Bopp had come just a few months earlier, it would have passed very, very close to the Earth indeed. And as it was, Hale-Bopp came at just the wrong moment. The Earth was almost the other side of the Sun at the time, and Hale-Bopp was a long, long way away. Now, if Hale-Bopp had come as close as Comet Hyakutake had come, it would have cast shadows. It would have been nearly as bright as a crescent moon, half moon, and it would have cast shadows.
I wonder when we'll get the next shadow-bearing comet, because we can't tell. But at least we have got two possible naked-eye comets, as we said earlier.
Yes, there are two comets that are coming. They're getting closer to the Sun now. They're both well inside the asteroid belt now. One is, unfortunately, these are comets that have both been discovered by automatic telescopes, and so they have fairly horrible names. One is C2001Q4 NEAT for the NEAT telescope in Palomar, and the other is C2002T7 Linear for the Linear telescope in New Mexico. Now, they're getting in close. Linear is now just about a binocular object. They are brightening astonishingly rapidly, and they are continuing to brighten even when most people thought that they were going to start to get tired and fade out, as comets often do when they come in, because these are comets coming around for the first time. And those are comets that you know are not reliable. They're not to be trusted at all. But if they continue brightening as they are, they will be about 10 times as active as Halley's Comet when they're at perihelion. Now, Linear, that will come really very close to the Earth in May next year. Neat won't be quite so close, but it looks like a bigger comet. It would be nice to think, because if they do continue brightening, you'll go out at sunset, look at the twilight sky, and you'll have one naked eye comet there, and you'll have another one there, in the same visual field of view in late May.
I don't think it's ever happened before.
I can't think of a case that it's ever happened before. There have been two comets in the same year, separated by a few months.
I remember in my very first Sky at Night programme.
Exactly.
Comet Aaron Roland.
Yes, and then Comet Merkos in October, but that was separated by 6 months.
And sadly, Aaron Roland will never come back. It was put out by Jupiter and thrown into an open orbit. It will never come back to the Sun.
Yes, and that Aaron Roland was a very interesting comet because it was an Oort cloud object. It was an object coming around the first time. It's one that you think is not to be trusted. It will probably fade out when it comes close to the Sun, and it didn't. But Aaron Roland was a very special comet. It was a very dusty comet. And there is a suggestion that's been made that maybe Aaron Roland became so spectacular because it was a very dusty object.
Well, I wonder how these two will develop. Of course, they won't be back for thousands of years.
No, exactly. In fact, they are very, very long period objects. They've come in from the Oort cloud. They've taken many tens of thousands of years to fall down from the Oort cloud. I don't know if we know what the future orbit will do. No. I think they'll go back out to the Oort cloud. It will be very interesting to see what they do.
Well, the only bright comet that we see regularly, of course, is Halley, back in 2061, but it won't be good even then.
No, it won't be. But if people are patient, if they wait till 2135, Halley's comet will be very, very good in 2135. It will come close to the Earth. And there's another spectacular one about the same time in 2126. Swift-Tuttle will come back. That will pass very, very close.
And that it was once suggested that might even hit us.
Latest calculations are it can't hit us in the next 1,000 years. But it will come, had the orbit been very, very slightly different, 12 days earlier at perihelion and its next return, it could just have hit the Earth. It won't, but it will pass very close by. It will be quite spectacular. So if viewers are patient, they make a note in their diary for about 2126, they'll have two very, very good comets.
Of course, one point, you know, where we could be hit.
We could be one
day,
not
by this one, but we could be hit by a comet.
One day, we will be hit by a comet. We know we've been hit by comets in the past. We have been hit by objects even relatively recently. There was the great explosion in Tunguska in 1908.
Yes, what was that? Was it a meteorite or a comet or what?
Well, I don't think we'll ever know, but the balance of probability, I think, at the moment, is that it was a small asteroid, a very small asteroid, possibly about 20, 30 metres in diameter. We do know it exploded about 8 kilometres above the surface, and the explosion was around 30 megatons. So that was a very, very big bang, and we were lucky. It fell somewhere that was deserted.
We were indeed.
We were very lucky.
Well, Mark, looking ahead now, what do you expect from these new comet probes?
We are going to learn an awful lot. We don't really know too well what a comet is like. There is a lot of evidence. The comets that we've seen that have broken up, comets like Comet Linear in 1999 that just fell apart, completely fell apart. And comets that have split, like one, the Contour mission was going to go on to a comet called Strassmann-Wachsmann 3, which in 1995 split in 5 pieces. Now, that would have been fascinating because we could have gone to a comet and seen why the comet split into so many pieces. But you've got to get very close in and look.
Mark, it's been great to see you all the way from Canary Islands. Thank you indeed. It's been delightful to have you once again on the Sky.
Thank you very much indeed, Patrick.
Next month, we're going to deal with music and astronomy. But we can't forget Mars. Give the results of our Mars photographic competition. And don't forget, on Christmas Day, Beagle 2 lands on a Martian crater and carries on the search for Martian life. So it's going to be very exciting indeed. And since our next programme won't be until next January, I hope it's not too early for me to wish you all a very happy Christmas and New Year. For now,